So welcome back. We're going to continue graphing linear equations. This time we're going to do it a little bit different. Instead of trying to find these three solutions, we're going to go a little bit different direction. We're going to what we call use x and y intercepts. Remember, as we discussed just the last video, x-intercept would be a point on the x-axis. The y-intercept would be a point on the y-axis. So one thing to pick up on is, if you're on the x-axis, notice that your y value has to be 0. You can move left and right, so your x value is unrestricted, but your y value is locked in. It has to equal a 0 to be on the x-axis. Similarly, if you're on the y-axis, the x is locked in. X has to equal 0. But the y value is unrestricted. It could have been anywhere along this y-axis. So y does not have a restriction. It can be any number it wants to be. But that x is locked in. That x has to be a 0. So we make a note then that if we want to find an x-intercept, in other words, it's a special order pair where x is some number but y is 0, what I can do to find an x-intercept is simply set y equals 0 and then solve for x. Similarly, if I want to find a y-intercept, again, x is going to be locked in. So I'm going to set x equals 0. This is going to enable me to solve for y. So once I identify those two intercepts, the x and y intercepts, I'm going to plot those intercepts, and that's going to allow me to graph the line. So actually, we're only going to find two solutions this time. But we're going to feel pretty good about this math because when you work with 0, the math becomes a lot easier, and there's very few errors in the math. We usually get it right the first time. So let's go about finding the x-intercept. So the x-intercept says set y equals 0. So in this equation, I'm going to have then 4x plus 3 times 0 is equal to 12, which means I'm going to have 4x plus 0 is equal to 12. In other words, all I really have is 4x equals 12. So when I set y equals 0, this term essentially just falls out of the problem, and we have 4x equals 12. So then I can just divide both sides by 4, and that's going to give me x equals 3. So x is going to equal 3, and y was equal to 0. That is going to represent my x-intercept. I'm going to make a little note there. A lot of times, x-intercept is abbreviated like that. Now if I want to find the y-intercept, I'm now setting x equal to 0, and I'm now solving for y. So I'm going to substitute in 0 for x. 4 times 0 plus 3y is equal to 12. And we pick up on, this is just going to fall out of the problem. So all I really have is then just 3y is equal to 12. Divide each side by 3, and y would equal then a 4. So my y-intercept, therefore, is going to be 0, 4. So again, as an ordered pair, this would be 3, 0. As an ordered pair, this would be 0, 4. So those are my coordinates of my intercepts as well. So when I graph the intercepts, we see that 3, 0, 1, 2, 3, 0 would be here. That's my x-intercept. My y-intercept would be 0, 4. That would be locked in there. And now, the line is just going to be drawn through those 2 points. So I'm going to try to use a straight edge and line up these 2 points. This makes it a little bit easier too, because that third point always causes me an issue. But I can kind of sketch that out, and we can kind of see that will be our graph of the line. So again, remember the line itself represents all the ordered pairs that satisfy this equation, all the values of x and y that make that equation true. All we did was find 2 solutions, and that allowed us to create the whole solution. Okay, so the line itself represents all the solutions. We identified only 2 of those solutions, which were very special. They were the x and y intercepts. And that's how we go about graphing linear equations. This works really well when you see equations where that x and y are on the same side, and we have what we call the constant on their side. This x and y-intercept works really well when it's in this form. So take note of how that equation is written. That could be some signals of strategies that are most effective in graphing the solutions. So we'll try one more.